So as you can probably tell, given the title of this chapter, it is mostly going to be calculation based. So we do have our derived units and density in this section. Alright, so units, obviously you're going to have a lot of different units depending on what you're measuring. So for mass, it is a measure of the amount of matter in an object, and it will not change. That's of course based on like if the object itself changes shape, size, then mass would change. But if something like that doesn't happen to the object, then the amount of matter will not change. Okay, now this becomes important when you start talking about weight. So here on Earth, we generally tend to use mass and weight interchangeably. They are not actually the same. Okay, so weight is a measure of the gravitational pull on matter. Okay, so it's not a measure of the amount of the matter, it's a measure of that gravitational pull on it. So if there is more matter involved in something, you're going to get a greater gravitational pull, so the weight will be more. But the weight, because it's based on gravitational pull, will change if you are, say, an astronaut and you go up into space. Okay, there is little to no gravitational pull, so your weight decreases drastically. If you're on the moon, if you go to a different planet, so on and so forth. But the mass will stay the same no matter what planet, moon, space, whatever you're in. Okay? So derived units are combinations of SI base units. Now, you're probably a little bit more familiar with these than you might think. There are a couple that are going to be really new to you. So, for instance, pressure is generally measured in pascals, but pascals is not actually an SI unit. It is a derived unit. So 1 pascal is equal to 1 kilogram per meter second squared. It's a very odd unit, which is why we use pascals instead of saying that entire unit every single time. Okay. So some of the ones that you're probably most familiar with would be area. Okay, so you've got square meters. So meter is your SI base unit, but then because you're multiplying two lengths, so a length times a width, you get meters squared. So that is a derived unit. Okay, and then when you've got volume, you go 3D instead of just 2D, so you add in a third distance or third length there. So it's length times width times height. So now you have cubic meters or meters cubed. Density is very similar to that. Okay, you're going to have some kind of mass unit over some type of volume unit. Now, that can come in a lot of different forms. So kilograms is your SI unit, and then meters, again, is your SI unit. So kilograms per meter cubed. Okay, because remember, this has to be a volume unit. So this is kind of like a double derived unit, because you've got your volume unit, meters cubed, is derived, and then when you put it together with the kilograms, you get another derived, kilograms per meter cubed. Okay? And we'll get into the other ones later, so we don't need to work on that just yet. So for volume, the derived SI unit is cubic meters, so meters cubed, though centimeters cubed is also very common. It really depends on the size of whatever you're measuring. And then the liter, which we're most familiar with in the metric system as being the volume unit, is a non-SI unit. Okay, it is actually based on centimeters cubed. So 1 liter is equal to 1,000 centimeters cubed. And on kind of the flip side of that, 1 milliliter is also equal to 1 centimeter cubed. Okay, so it's a very easy conversion, really. Just 1 centimeter cubed is the same as 1 milliliter. Okay, but it's just milliliters and liters are a little bit easier to work with than centimeters cubed and all of that. So density, when we get into this, your density formula is mass divided by volume. So density is known as the ratio of mass to volume. This goes into how packed the matter and the atoms in a certain object are. Okay, so if you compare the same mass of feathers to the same mass of, say, wood, okay, you can tell that the wood is much denser. Its material, its matter, is much more packed in there, okay? And you can tell that because if you were to hit somebody in the face with, say, a pound of feathers versus a pound of wood, okay, which one would hurt more? Okay, it's because you have more atoms in that same mass, okay, or in that same space, basically hitting you in the face, okay? So the wood would obviously hurt a lot more. So density equals mass divided by volume, oftentimes shortened to capital D equals M divided by capital V. Okay, and the SI derived unit is kilograms per cubic meter. So this is going back to using your 7 SI units, the kilogram and the meter. Okay, so oftentimes you will not actually see density listed as kilograms per meter cubed. Okay, oftentimes it'll be grams per centimeter cubed, it'll be grams per milliliter, different things like that. Okay, so those are the more common ones, but kilograms per meter cubed is the correct derived unit. Okay, and then density is actually really useful because it is a characteristic physical property of a substance, meaning it is one of those properties you can use to identify an unknown substance. So, for example, okay, we've got a list of different densities of some common compounds. Okay, so you've got your solids on the left, liquids on the right. You can see as you look at this that generally your metals are denser than anything else. Okay, so you see the densest one on here is mercury at 13.6 grams per milliliter. And then you've also got, different substances like cork are your least dense. So if you think about cork and then compare it to lead, okay, so cork you've got 0.24 grams per centimeter cubed. Lead is 11.35 grams per centimeter cubed. So you can see the difference right there with that number. And then if you think about the two compounds, you can also kind of see how different they are. Okay? A cork, if somebody threw it at you, whatever, it's just going to bounce off you, it's not going to hurt. Lead, on the other hand, is quite another story. Okay? If you get hit with lead, it's going to hurt. Okay? And another thing to look at here is we've got the density of ice, and then over here we've got the density of water. Okay, you'll notice that water, the liquid form, is denser than ice, the solid form. That is actually a relatively unique property to water. Generally, the solids are the densest form, and then as you go closer, go from solid to liquid and then liquid to gas, you're getting less and less dense. Okay, but water is unique, or not entirely unique, but mostly unique in that water, the liquid form, is the densest. And that's why ice floats. Okay, little lesson. And that goes into how all of the atoms are arranged within the substance. Okay, so for an example here, we have an object that has a mass of 25 grams and a volume of 2.8 milliliters. So what is the object made out of? Okay, now generally you don't want to, if you're trying to actually identify the identity of a substance, you don't generally want to kind of base all of that on a single property. Okay, because basically if you look here, we've got butter. Well, let me get my pen, that might help. Here we go. So here we've got butter, right here, has a 0.86 grams per centimeter cubed density. And then over here we've got turpentine, has 0.87. So those are really close, and that is not a mistake that you would want to make. Okay, that could end up very, very badly for you. So you don't just want to go off of one property, okay? But with this, we're just going to be focusing on identifying a property using its density. Okay, so we've got our density formula. Density equals mass divided by volume. Okay, and we're given our volume here and our mass here. Now, one thing to note are the units. So if we look down at our chart that we have to compare it to, okay, we've got grams per centimeter cubed here, but we're given milliliters. Okay, but again, if you remember from one of the previous slides, 1 milliliter is equal to 1 centimeter cubed. Okay, so those can be used interchangeably. So we don't really have to worry about that right now. So now we can just go ahead and plug in our numbers. So we've got 25 grams and we've got 2.8. We'll go ahead and change it to centimeters cubed. All right, so if you do that calculation, you'll find that the density is roughly equal to 8.92, and then it's grams per centimeter cubed. Okay? And sorry, I'm having to write with my finger, so it's really kind of large and sloppy. I usually write with my mouse, but it doesn't want to work right now. So, okay, so if we've got a density of 8.92 grams per centimeter cubed, we're going to look down our chart here, and we'll see that copper has the same density. Okay? Now, of course, if this is actually copper, it's going to have that kind of coppery color. It's going to be a metal. You can tell that it's a metal, and it's going to have other properties that are the same, okay, that help you identify it as copper. So you're not just looking at the density, but in this case, if I said it's copper colored in the problem, that would be a very obvious hint. Okay, so we're actually going to take a break here and continue with this on the next video.